Continuing on with these adding and subtracting radicals, we're now looking at things under the cube root. So the main thing we have to adjust is when we're looking at our common squares and cubes, we want to be looking at the third column, the cubed column. I start by trying to break down 48. Start with 27, does not go in evenly. Try 8, it does go in evenly. It breaks into the cube root of 8 times the cube root of 6. Again, I want to be paying attention to the imperfect part that's left over. If this 8 is a perfect cube and it's the right one that we've pulled out, then for these to combine, this root 6 has to be what's left over. So I'm going to try to divide what's under the next one by what was left over 6. If I divide 384 by 6, I get 64, which is a perfect cube. It appears on my list. So I can break this into the cube root of 64 times the cube root of 6. On my list, 8 goes back to the number 2, so I get 2 the cube roots of 6. Minus 64 goes back to 4, so minus 4 the cube root of 6. 2 minus 4 gives me negative 2 cube roots of 6. For number 8, we have 270 as our first number, so 216 is what we're going to try. Doesn't go in evenly. After 216, I try 125, doesn't go in evenly. Then I try 64, doesn't go in evenly. Then I try 27. My calculator says 270 divided by 27 does give me a whole number, specifically 10. So I break this into the cube root of 27 times the cube root of 10. Now that I know a 10 is going to be left over, I try this divided by 10. 1250 divided by 10 gives me 125, which is on my list of perfect cubes. So I break this into the cube root of 125 times the cube root of 10. Cube root of 27 points me on my list to 3. Cube root of 10 left over. Plus cube root of 125 points me to 5. Still cube root of 10 left over. 3 plus 5 gives me 8 total. Cube roots of 10. When I go to try 2000, my first opportunity that I'm going to try is with 1728, which is 12 cubed. Doesn't work. Then I try 1331. Doesn't give me an even number. Then I try 1000. 2000 divided by 1000 gives me 2, which means it does go in evenly. So I can break this into the cube root of 1000 times the cube root of 2. Now that I know 2 is what was left behind, I can try dividing my next term by 2. 54 divided by 2 is 27, which is on my list. So this breaks into the cube root of 27 times the cube root of 2. Again, to make it easier on myself, I start by trying to divide what's inside by what I know should be left over. 1458 divided by 2 gives me 729, which is on my list. It's 9 cubed. So this becomes the cube root of 729 times the cube root of 2. Again, I want to break these down. So this 1000 goes back to 10 as far as what it is cubed. 27 goes back to 3. And 729 goes to 9, all with a cube root of 2 after it. When I combine these, 10 plus 3 gives me 13. Minus 9 gives me 4 cube roots of 2.